Let's look at 5.3D reference angles. So let's talk about the different quadrants. So notice that on our notes we have quadrant 2, 3, and 4. So let's first talk about quadrant 1. So I'm going to write that up here. So this is quadrant 1. And we know that this is our initial side, and then this is our terminal side. And it goes like this. That is our angle, that is theta. Okay, so we need to find out the acute angle formed, theta prime, formed by the terminal side. So we're going to call this theta prime. All right, so let's look at just theta versus theta prime. What we found out in our last sections is sine of theta is the same thing as sine of theta prime. We're going to just dig a little bit more into our angles so that we can determine reference angles. And so for quadrant 2, so that is whenever this is still our initial side, right? And then this is our terminal side, and this is our angle. So this is theta. And then this, the triangle that's formed with our x-axis, like we learned last section, has theta prime as its angle. Okay, so in order to find theta prime in degree mode, we're going to do theta prime equals 180 minus theta. Okay, so then in radian mode, you got to think, what is 180? So theta prime is pi minus theta. Okay, so that's still our initial, that's our terminal, and then we have the two angles. So see how they form this x-axis, the straight line? That's why we use the 180. Okay, let's go to quadrant 3. So this is our initial side still, and then it goes over into quadrant 3. So we have this angle right here. That's our theta. But we want to find theta prime. So we make a right triangle. So theta prime is right here. So we know 180 is the straight line, and then it's a little bit more than 180. So what we have to do for degree mode is we have to find theta prime is theta minus 180. Because see how theta is the obtuse angle? Obtuse. So that's why we're able to do the obtuse angle minus the 180. On quadrant 2, it was the acute angle. Well, this was also obtuse, but we're always trying to find theta prime, which is the acute angle. Okay, so then for radian, we exchange 180 with pi. Okay, then in quadrant 4, this is still our initial side, so this time it goes to here. So it's this whole angle right here is our theta. We want to find the reference angle. So I'm going to go ahead and draw my right triangle. So this is theta prime. The whole thing, the whole circle is 360. So it's going to be 360 minus theta. So in degree mode, theta prime is found by doing 360 minus theta. And then for radian mode, it's found by doing the radian equivalent to 360, which is 2 pi. So we're going to use these to help us, okay? So find the reference angle theta for angle theta. No, well, that says angle theta prime. So theta prime is going to be our acute angle, okay? This is our reference angle, and it's the acute angle. That's what we're looking for. So if it's not acute and it's not positive, then we have to do some work. Okay, so go ahead and draw your coordinate grid. So 158 degrees. So we know this is 0, this is 90, this is 180. Just think back to your unit circle, so on. But if I'm going 150, then it's going to go, let's say, to right there. So this is theta. Theta is 150. So we need to find, I'm going to draw my little right triangle, theta prime. So see how we're in quadrant 2? So then look right above in our rules. We are going to find out 180 minus theta. And what we're going to do is just to decide whether it's in degrees or radians, we look at what we're originally given. So this is degree. So we are going to give our answer in degrees. So theta prime is found by doing 180 minus theta. So theta prime is 30 degrees. Okay, let's go to 2. Theta is 315. So think back to your circle, 0. This is also 360. This is 270. So 315. It's going to be this to this. So all the way there, 315. So we need to find, I'm going to draw my right triangle, theta prime. So we are in quadrant 4. So look back at our instructions for quadrant 4. It says 360 minus theta. So to find theta prime, I'm going to do 360 minus 315. So theta prime is 45 degrees. Okay, number 3. Now we have a negative 315 degrees. So this is negative 360. This is negative 270. So it's just a reflection across the x-axis. So it'd be, this is our angle, this is our angle. So it goes around like that. So it's negative 315. Make your right triangle, theta prime. So we need to take 360 away from it. Though if we take 360 away from negative 315, we're going to get a bigger negative number. We don't want that. So instead, well, I guess we would do the same thing, right? We would do 315 plus 360. And that is 45 degrees. And that is an acute angle, so we can leave it just like that. Okay, the next ones, they are written in radians. So we're going to give our answer in radians. So when we do our rules, we're going to use the ones on the bottom, the one that deal with radians. So 3 pi over 4. So you might need to get out your unit circle. I'm going to get out mine and look at it. And I know this is 0. This is pi over 2. And this is pi, which would be like 4 pi over 4. So 3 pi over 4 would be right here. So I'm going to make my right triangle, theta prime. So I need to find out, so this, see how this makes a straight line? And we're in quadrant 2. So that means we use the 180 rule, which 180 in radians is pi. So it's going to be pi minus theta. So theta prime is found by doing pi minus 3 pi over 4. And we want to leave it in terms of pi, so we're going to have to find a common denominator. So I'm going to multiply times 4. So theta prime is 1 pi over 4, or just pi over 4. Let's go to number 5. Negative 5 pi over 4. So if you look at your unit circle, it's usually down in quadrant 3, but because it's negative, it's going to be up in quadrant 2. And it went around like this, right? Theta prime. Okay. So then we would use the rule that it's theta, the negative 5 pi over 4, minus 180. Which really we need to just find our coterminal angle. So let's do that. To find coterminal angle, you're going to plus and minus 360, which actually, that's what we were doing here. We were finding our coterminal angle. We do the plus or minus 360. So we did plus 360, and we found the coterminal angle, which actually ended up to be acute. So that's how we were able to say that theta prime was 45. Okay, so let's find the coterminal angle to 360, which is really 2 pi, because it has to be in the right terms, or right mode, I guess. So I'm going to do negative 5 pi over 4 plus 2 pi. So we got to multiply times 4 times 4. So it'd be 8. So that'd be 3 pi over 4. Much better. Which, isn't that what we just got through doing on the last problem? So we do theta prime equals pi minus 3 pi over 4. Because what we could do is we could say that that is 3 pi over 4. So since this would be in quadrant 2, Q2, we're going to use the Q2 instructions, which say pi minus theta. So basically what we're doing is we're ignoring that this is negative altogether and just looking at that and looking at this. Okay. Let's go to the next one. 11 pi over 6. So that is almost 12 pi over 6, which is 2 pi. So it's almost a full revolution. Okay. So 11 pi over 6. So you can use your unit circle to know where exactly that falls. Draw your right triangle, theta prime. We know theta is 11 pi over 6. So then we are in quadrant 4. So we use the rule up here, 2 pi minus theta. So theta prime is found by doing 2 pi minus theta, 11 pi over 6. Got to do the work, so times 6. So 12 minus 11 is 1, so theta prime is pi over 6. Okay, we are going to do 7, 8, and 9 in class. Okay, let's look at the next page. Evaluate sine, cosine, tangent on the angle using the unit circle. So this is a bit of a review. So you'll need to look at what the x and y, what the coordinate pair is for each one of these angles, and then use your sine, cosine, and tan. So all at once is sine, cosine, and tan. Okay, so I'm going to skip that one. 13 through 14 is a review as well. So let's look at 15. So use the given value and given constraints to find the remaining trig ratios. So I'm just going to give you a pointer here. So cosine, if you look at your formula chart, cosine is x over r. So that tells me that x is negative 3. That's what I know. And then it says sine of theta is less than 0. So let's look at what sine is. Sine of theta is y over r is less than 0. So that means that it's negative. R is always positive, so this one has to be negative. So I'm going to kind of write it like that. So let's go ahead and look. So negative, negative, that means we're in quadrant 3. So I know it's negative 3 as my x. I don't know what my y is, but I know that my r is 7. So now you can use that information to find your missing side and find your trig ratios. All right, we will finish this in class.